Let us now see some examples of operations between functions and also to address a key issue that we left unresolved. Namely, what is the domain of these functions? So let's see the first example. We start with f of x, which is by definition x squared plus 1, and, well, the maximum, the largest domain for these functions is all real numbers, R, but I'm going to choose a subset of those. So let me specify the domain of f as being from -3 to 1. Okay? And the second function, g of x, is by definition 1 over x. And the domain, let me choose the domain for this thing, the domain of g, goes from -1 up to 10. Okay? Let's now see, well, if I now make the summation of these two functions, what do I get? Well, f plus g, the new function, when acting on the number x, is by definition, well, x squared plus 1 plus, so this is the first function, plus 1 over x. Okay? Every single time I want to evaluate this function, well, I need to choose an x, okay? And so I need to compute this thing and this thing at that x. But I must choose then an x where both calculations can be realized, okay? This is very important. To compute this thing, this single number, you need to compute two pieces and then operate. You see? Remember the three steps? Evaluate one, evaluate the other, and then sum. Okay? But first, you need to step number 1 and step number 2. Okay? But for that, you need to choose x's that live in the domain of f, and the x must also live in the domain of g. So, you can only choose x's that simultaneously belong to these two pieces. Okay? Is it clear? Okay? And so, in other words, let me write explicitly now, the domain of this new function, f plus g, must be the intersection of this thing and this thing, meaning those numbers that are in this thing and in this thing. Okay? So it's the intersection of domain of f intersecting with domain of g. Notice one thing. This is very important because I already made a mistake here. Okay, can you see? Because I said that the domain of g is from -1 to 10, but that's not quite right. Because since it's 1 over x, you need also to avoid the x being 0. So it's from -1 to 10 except the 0. Okay, because at 0, this thing is infinite. Okay? So intersecting now this thing with this thing, that's now fixed. What do we get? Well, you get from -1, okay, up to 1. Can you see? Well, if you cannot see, let me make a picture. It's probably better to make a picture for this thing. See, it's a real line. Here's the 0. Here's the -1, -2, -3. Here is -1. And then you have things up to 10. So you have 1, etc. up to 10. And now the domain of our first function goes from closed, -3, up to 1, closed. And now the domain for the second one is from -1, closed, up to 10. But you need to avoid this thing here. So it's open here. Okay? So the intersection of the blue thing here and the green thing here, well, let me put it in red. It goes from this thing here, closed, up to here, open, and then again closed. Okay? The intersection. Okay? And so as a result, the intersection of these two domains goes from -1 up to 1 except 0. Okay? And this thing is the domain of our new function that we constructed. Is it okay? What is the difference now? If you introduce, instead of plus, introduce here a multiplication symbol. So it's a dot now. So we have a dot, here a dot. What is the difference? Well, to compute the product between these two functions, we need to compute the product between these two numbers. But you see, you first need to evaluate them as well. And so the domain is essentially the same thing, okay? Because you need this, so you need the intersection between those. One more example. What about the subtractions? Well, subtraction is quite easy because it's just the same thing as the summation, okay? Finally, what about the division? What if I introduce here the divide symbol between this thing and this thing? What do I need to change? Well, when I divide something by something else, that something else I'm divided by which is in the denominator, that thing here, cannot be 0. But notice, 1 over x is never 0. So there is no problem. The domain for the division is also this thing as well. There is no extra x that I need to remove, well, because this thing is never 0, 1 over x, okay? So for 3 operations, the same domain. Now, let's see another example. Let's erase this. And the second example we are going to consider is as follows. Let us see. So you have x plus 1 and square root of x. And let's choose for the domain of f all the real numbers. And the domain for the square root here is all real numbers that are positive or 0. Okay? Because now let's do it again. Summing the two functions acting on x gives us x plus 1 plus square root of x. And as you can see, now the operation is easy. You just intersect the domain of this thing and this thing. So the domain of our function, f plus g, must be what? Well, r intersection with r plus 0, but because r is larger, it contains this thing. Well, the intersection is again r, positive or 0. Okay? The same result you get whether you put here a multiplication symbol or a subtraction symbol. So, multiplication or subtraction. Multiplication or subtraction. Is it okay? What about the division? The division now has something new here, right? If I introduce here the division. Because remember, when you divide this thing and this thing by this thing cannot be 0. Okay? You see, if you work with numbers, let me see, if you work with x's living on this thing, on r, or positive numbers including 0, there is no problem in evaluating this thing and this thing separately. But you will have a problem when you divide them, because it is possible by choosing x equal to 0, well, this thing becomes 1. There is no problem in that evaluation. You can put it x equals 0. There is no problem in that calculation. But there is a problem at the third step, because then you have to divide 1 by 0. And so, when you are talking about division, let me put here downstairs, f divided by g, well, you need to remove from this thing here, from the intersection, so it's again r intersection with r plus 0, though the domain that you need to evaluate them individually, and then you have to remove from this thing those x's that make the denominator 0. So you have to remove 0. Okay? So this handles the first two steps, and this handles the third. Okay? In the operation implicit in this symbol. Now, this is the second example. Let's now see a third one. The third one, after a while you start to see the idea. The idea is always what you saw previously. So you get 1 over x and 1 over x squared minus 1. What is the domain, the largest domain for f? The largest domain for f, well, you already know. It's all those x's on the horizontal line, except those at 0. So it's r, excluding 0. The domain, the largest domain for this g, is all those x's that prevented the denominator from being 0. So either plus 1 or minus 1. So it's r excluding plus 1 or minus 1. Okay? What about now? You can now make the division, subtraction, and so on for these two functions. But let's just focus on the domain, because everything else is quite easy. So the domain of f plus g is again this thing intersecting with this thing. Okay? Can you see? So it's r excluding 0, minus 1, and 1. Okay? The intersection of these two sets. Okay? The same thing, the same result you get for the product and for the subtraction. What about the division? What about the division? Is this the same thing? The division, well, it is this thing plus an extra. The extra being you need to remove those x's that make the denominator 0. But you see, this denominator is never 0. This function never takes the value of 0. Okay? And so, for these 4 operations, the domain is always the same thing. Okay? Now, let us see the following. Let's now see one more example. One last example, in fact. A trickier one. So this is a tricky example. Let's assume that f of x is a function x. So it's the identity function. And g of x is also the identity function. So it's x again. If you now have f of x plus this thing, you get 2x, right? Because you are summing this thing. If you subtract, what do you get? Well, you get 0 all the time. Then if you multiply, you get x squared, right? And finally, the key one that I want to address with you is this one. Is x divided by x. This is the tricky one. These ones are quite easy, because if I consider the domain of f as being R, the domain, which is the same thing as the domain of G, now here you have intersection of R with R, which is again R, so the domain here is R. The domain here is again R, the intersection of both, and same thing for here. Okay? There is no x here that you cannot introduce here, that you cannot square. Okay? But here we have a problem. What is the domain of this thing? You should think about it. Stop the video and think about it before I give the answer. Okay? Okay? So we have here x divided by square, x divided by x. And so it's tempting to say, well, that is just 1. Okay? It's tempting to say that. But that's not quite true. Okay? Because, again, this function here, is only defined for all those x's as long as the domain is not 0. So the g here cannot be 0. So the domain of this function is R except 0. Okay? So it's yes, it is indeed true that is equal to 1 as long as you work on this thing. So when you see on any formula, from now on, every single time something like this appears, you cannot just cut this thing and say, well, it's 1. No, it's 1 as long as you assume this thing. Okay? Because you have to think when you have formulas with expressions like these, or any others, well, you have to think about the functions. You have to think what x's are possible or not. Okay? Because, again, a formula is just operation between different functions, and those different functions have domains. Okay, and depending upon the operation, well, for this one you need to use the intersection, but for this specifically is more than the intersection. It's also you need to remove the denominator when the denominator the x's that make the denominator 0. Okay, so these are all the examples. Now let's move on.